Hey guys, in this video I'm going to run you through all the solutions for June 2022 AS Paper 1 for AQA. Every question is going to be timestamped so you can easily skip to a question if you want to find that. Hope you find this helpful. Let's get started. So for question 1, it says, can we express as a single logarithm log base 10 of 2 minus log base 10 of x? Well, as it's subtraction, we can use the subtraction law for logarithms, which means we can simply just divide the argument. So that would leave us with log base 10 of 2 over x. So we'd circle the last option. Okay, and now for question 2, it says the graph of the function y equals cos of a half x for 0 to 360 degrees is one of the graphs shown below. Can we identify the correct graph? Well, the giveaway here is this half x, because if we think about f of x being cos of x, just the regular cos graph, what we have here then for y is f of a half x, which would be a graph transformation. Specifically, it would be a stretch in the x-axis by a scale factor 2. So if the regular cos graph repeats every 360 degrees, after the scale factor of 2, it's going to be every 720 degrees. So we're looking for a graph where one repetition is 720 degrees. Well, you can already rule out the first two. They're still repeating every 360. This one's actually repeating shorter than 360. And this one, it's showing half an oscillation being 360, which means a full oscillation would be 720 degrees. So that's going to be our correct answer. Okay, so now for question 3, it's saying, can we find the coefficient of x cubed in the expansion of 3x plus a half to the power of 4? So that's an integer power binomial expansion, so we can use the integer power binomial expansion formula, which goes like this. So a plus b to the n would equal a to the n plus n choose 1, a to the n minus 1, and a to the n minus 1, b to the 1, plus n choose 2, a to the n minus 2, b squared, plus dot dot dot, and then the rth term, which we're going to use, is going to be n choose r, a to the n minus r, b to the r. And we're only actually after the coefficient for x cubed. So we don't need to worry about evaluating the whole expansion. We just have to think carefully about which term specifically. So first off, I'm going to rewrite it as a half plus 3x to the 4, just reordering the terms in the bracket. And then we're going to think, okay, well, how does this relate to our formula? Well, I'm going to call a half then. I'm going to call b 3x. N is 4. And we're after the x cubed term. So if we look at the general form here, we want r to be 3 if we're going to get an x cubed term. So setting r equal to 3, then we can simply use the formula for the rth term to get our coefficient. So writing that out, we'd have 4 choose 3 times a half to the power of 4 minus 3, which should be to the power of 1, times 3x all to the power of 3. So plugging this in a calculator, 4 choose 3 is 4. Then it's times a half. And you have to remember to cube that whole thing. So 3 cubed and the x all cubed. So 3 cubed is 27. And then x all cubed is just x cubed. So we have 4 times a half times 27x cubed. Well, 4 times a half is 2. 2 times 27 is 54. So the answer for our term would be 54x cubed. So the coefficient would just be 54. Okay, and now for question 4, it says, can we find all the solutions of the equation cos squared theta equals 10 sine theta plus 4 for the interval of theta being between 0 and 360 degrees, giving your answer to the nearest degree. So the first thing we're going to have to do is actually rewrite this trig equation all in terms of one trig function. So the easiest thing would be to turn this cos squared theta into a sine squared theta. So if we remember that cos squared theta plus sine squared theta equals 1, then we can use the fact that cos squared theta must be 1 minus sine squared theta. So substituting that in, we'd have 1 minus sine squared theta would equal 10 sine theta plus 4. And then that's actually a quadratic in sine theta. So let's bring everything to one side and set it equal to 0. So if I take everything to the right hand side, we'd get sine squared theta plus 10 sine theta plus 3 would equal 0. And then if it helps us, we might want to use a substitution just to make it look a bit more like a usual quadratic. So if we say u equals sine theta, then we'd have u squared plus 10u plus 3 equals 0. And then to solve that, it doesn't really factorize particularly nicely. So I would complete the square. So what would that give us? It would give us u plus 5 squared, and we have to take away 25, and we'd have to add 3. That's equal to 0. And then solving that, that would give us u minus 5. Sorry, that would give us u would be equal to minus 5 plus or minus the square root of 22. And then we have to actually go back and solve for theta. So this really means sine theta equals minus 5 minus root 22, or minus 5 plus root 22. Well, the sine graph only actually goes between minus 1 and 1. So there's going to be no values of theta or solutions that we can get that give this output. So we'll forget about that. We just have to worry about sine theta being equal to minus 5 plus root 22. And then to solve that, we're going to get our first solution from our calculator. So make sure your calculator's in degrees. We'll do inverse sine of minus 5 plus root 22. And the first value you're going to get in your calculator will be minus 18.034, which actually isn't in this range. So we need to go and find the solutions that are in the range. So if we just think about the sine graph for a minute, the sine graph looks like this. So the solution we found is actually here, and we need to go and find these two solutions over here. So this little distance here is 18.034. So we can find this solution over here by just adding 18.034 onto the 180 mark. So we can, okay, let's do that. So that would give us 198.03, or to the nearest degree, just 198 degrees. And then this solution over here, we could actually get there by just adding 360, because it's the same point in the next repetition of the sine graph. So if we go and do that, we'd get 341.96 degrees, or to the nearest degree, that would be 342 degrees. And I'll just make sure I cross out this solution, as it's not in the range they asked for. And our two solutions would just be the 198 and the 342 degrees. And now for the next question, question 5 says, express 3x cubed plus 5x squared minus 27x plus 10 in the form of x minus 2 all multiplied by ax squared plus bx plus c, where a, b, and c are integers that we need to find. So that's going to be, we need to factorize our cubic basically. So to do that, we're going to use long division. So we need to divide x minus 2 into our cubic of 3x cubed plus 5x squared minus 27x plus 10. So the first thing we do in long division is we take the highest power of x in our thing to be divided and divide it by the highest power in our divisor. So that would be 3x cubed divided by x would give us 3x squared. So I'd write 3x squared in this x squared column. And now what we do is take our divisor and multiply it through on what we got. So we're going to get back first that 3x cubed from x times 3x squared. And then minus 2 times 3x squared would be minus 6x squared. And now we have to subtract off. So 3x cubed minus 3x cubed is just nothing, 0. And then we have to watch out here, there's going to be a double negative. 5x squared minus 6x squared is going to give us 11x squared. And then what I like to do is write down the next term, again, the next power of x. So just bring it down so I can see it in one row. And then we repeat that process. So we take the highest power of x yet to be divided, which is 11x squared, and divide it by the highest power of x in our divisor. So 11x squared divided by x just gives us 11x. So we write down 11x in our x column, and then we multiply through again. So x times 11x gives us 11x squared back. And then minus 2 times 11x gives us minus 22x. We've got to watch out again here for a double negative. So it's minus 27 minus 22, so plus 22. That's going to leave us with minus 5x. And again, I'm going to bring down this to here, just so I can see it all in one row. So that would be plus 10 on the end here. And then we divide through again. So the highest power of x has to be divided, minus 5x divided by x. So that's going to give us minus 5. So I write minus 5 in the top here. Multiplying through just to check we've actually got a remainder of 0. We'd have minus, we get the minus 5x back. And then minus 2 times minus 5 is plus 10. So we do indeed get the remainder of 0. So our cubic then factorizes to x minus 2. And then this is our other bracket here. So it would be x minus 2, 3x squared, plus 11x minus 5. For question 6, it says AB is the diameter of a circle where A has coordinates 1, 4 and B has coordinates 7, minus 2. Can we find the coordinates of the midpoint? Well, to find the midpoint between any 2 points, we simply just average the coordinates or add them up and divide by 2. So the midpoint is going to have coordinates of 1 plus 7 divided by 2, and 4 plus minus 2 divided by 2, which if we simplify that down, 1 plus 7 is 8, divided that by 4 is, divided by 2, sorry, is 4. And then 4 plus minus 2, that's 2, divide that by 2, that's 1. Then it says, can we show that the equation of the circle may be written as the following? So any circle equation can be given in the form x minus a squared plus y minus b squared equals r squared, where that's where a circle has center with coordinates a, b, and the radius r. So we've actually already found the center in the previous part, because if AB is a diameter, then the midpoint of those 2 points is the center of the circle. So we know A and B to be 4, 1. And to work out the radius, we can just take any point on our circle, so A or B, and find the distance to the center for the radius. So I'm going to use the points 1, 4, and our center 4, 1. So using some Pythagoras, we're going to see that the radius is going to be the square root of 4 minus 1 squared, the difference in the x's, plus 1 minus 4 squared, the difference in the y's, which would be the square root of 3 squared plus 3 squared, so 9 plus 9 is 18. And I'll just leave it in that form because we're going to wind up squaring it in a second anyway. So substituting what we know into the equation of our circle, we'd have x minus 4 squared plus y minus 1 squared equals root 18 all squared, but that would just be 18. And then we need to expand out the brackets to get it in the form they asked for. So x minus 4 squared, expanding that out would give us x squared minus 8x plus 16. Expanding the other bracket would give us y squared minus 2y plus 1, and that's still all equal to 18. And if we simply just collect all the terms now, we do have an x squared and a y squared. We have our minus 8x and our minus 2y. And then collecting the constant terms, on this side we have plus 17. So if we bring that over to the right-hand side, subtracting 18 minus 17 is just going to be the 1, which is the result they asked for. Question 6c then says, the circle has center C and crosses the x-axis at the points D and E. Can we find the exact area of the triangle DEC? Well, the first thing I'm going to do is just recall our equation for the circle from the last part, so that's there. So we know the center and we know the radius. And now I'm going to draw a little diagram. So here's some axes for us. And let's draw a circle. It's going to be something like this. And our center is at 4, 1. So let's say that's about here. And the triangle they're recalling, so that's point C, the center, and it crosses the x-axis at points D and E. So that's these 2 points there. So to find those 2 points, that's where, along the x-axis, that's where y equals 0. So if we substitute y equals 0 into our equation, we're going to get x minus 4 squared would equal, plus 0 minus 1 squared equals 18. So then minus 1 squared is just 1. So take that over the other side, we'd have x minus 4 squared would equal 17. So x is going to equal minus 4 plus or minus the square root of 17. So this coordinate here must then be minus 4 minus root 17. And this coordinate here must be minus 4 plus root 17. So the difference, or the width of these guys, is just going to be 2 lots of root 17. Root 17. And the height of this triangle, because we want to find this triangle DEC, let's do it in red so we can see it a bit better. So there's our triangle there. So the base is 2 root 17, and the height from the x-axis, from the x-axis, we can just get from the y-coordinate, which is 1. So to work out the area of our triangle, it's just going to be a half the base times the height. So that's a half times 2 root 17 times the height of 1. So times 1 does nothing. A half of 2 root 17 is just going to be root 17. So the area is root 17. And it's important we leave it in that form because they asked for the exact area. So we can't leave it as a decimal. It needs to be an exact number. So either a fraction or a surd. So yeah, the answer is root 17. Question 7 then says, a curve has equation y equals a squared minus x squared, where a is a positive constant. The area enclosed between the curve and the x-axis is 36 units. Can we find the value of a? Well, the first thing I want to do is be able to visualize or have a diagram of this area that they're talking about. So let's draw some axes so we can plot our graph. So this is our y-axis here, this is our x-axis, and then overall this is a negative quadratic, so it's going to be an N shape overall, and then we can easily think about where it's going to intercept the axes. So when x equals 0, we're going to get y equals a squared, so it's going to intersect the y-axis at a squared, so let's say it's there, and then it's an N shape, so it's going to do this kind of thing. And we can find where it intersects the x-axis by setting y equal to 0. So if y is equal to 0, we'd get a squared minus x squared equals 0. Solving that would just give us x equals plus or minus a. So that would be a, and that would be minus a. And the enclosed region they're talking about is this region here. So we've been given information about that. So that's how we're actually going to solve the question. So if we were going to actually calculate that area, we'd have to use an integral. So we'd integrate the curve between minus a and a. So we must know then that the integral between minus a and a of a squared minus x squared dx must equal 36. So if we perform this integral, it's going to give us something for a, or equation to solve for a at least. So doing the integral, a squared is just a constant. So integrating that would just be a squared x. Then x squared, integrating that, increase the power by 1, divide by the new power. That would give us minus a third of x cubed. And then all that must equal 36. Oh, and sorry, with the limits between a and minus a. So now substituting in the limits, we're going to get, substituting the top limit, we'd have a squared times x is just, sorry, a squared times a is a cubed, minus a third of a cubed. And then the bottom limit, a squared times minus a would be minus a cubed. And then minus a third of minus a all cubed, that would also be minus a cubed. So that would wind up being plus a third a cubed. And this is all still equal to 36. Simplifying down, we're going to get 2/3 of a cubed. And then in the second bracket, we're going to wind up getting, well, minus a cubed plus a third. That'd be minus 2/3 of a cubed. But we've got a double minus, so it's going to wind up being plus 2/3 of a cubed. This is all still equal to 36. So we'd have 4/3 a cubed equals 36. And then 36 times 3/4, oops, gives us 27. And then the cube root of 27 is just 3. So the answer for 8 must just be 3. Question 8 now says, a curve has equation y equals x cubed minus 6x plus 9 over x. Show that the x coordinates of the stationary points satisfy x to the 4 minus 2x squared minus 3 equals 0. So to find the stationary points of any equation, we're going to simply set the derivative equal to 0. So we need to find the derivative first. So starting with our equation, we have y equals x cubed minus 6x plus 9x to the minus 1. Differentiating that, we'd get dy by dx to equal 3x squared minus 6 minus 9x to the minus 2 to be equal to 0. Well, we're going to set it equal to 0 if we want to find our stationary points. And then to get it in the form that they asked for, well, the first thing I notice, there's no negative powers of x in there. So I'm going to get rid of this x to the minus 2 by multiplying by x squared. So if I multiply everything by x squared, I'd get 3x to the 4. Then I get minus 6x squared. And then I get minus 9. And that's still equal to 0. And then there's a factor of 3 on everything there. So if I divide everything by 3, I'd get x to the 4 minus 2x squared minus 3 equals 0, which is the result they asked for. And now it says deduce that the curve has exactly 2 stationary points. So basically, to find the stationary points, we need to solve this equation. So this is actually a quadratic again, but a quadratic in x squared. So if we use the substitution u equals x squared, if that's going to help us, we'd say we'd have u squared minus 2u minus 3 equals 0, which actually factorizes quite nicely into u minus 3 and u plus 1 equals 0. So that would mean the solutions would be u equals 3 or minus 1. Or really, we need to solve for x. So x squared would equal 3, or x squared would equal minus 1. Well, this does give us two solutions, because if we square root, we'd get x to be equal to plus or minus root 3. Oh, sorry, this is an x squared over here. And x squared equal to minus 1, that actually doesn't give us any solutions, because there's no numbers, no real numbers, that we can square to give a negative. So there's no solutions from that, so we're just left with the 2 from here. Question 8c now says, find the coordinates and the nature of the two stationary points. So to find the coordinates, we're simply going to plug in our x coordinates that we already found of plus or minus root 3 into the original equation, which was y equals x cubed minus 6x plus 9 over x, so x cubed minus 6x plus 9 over x. If we substitute those in, so substituting x equals plus root 3 in, using my calculator, that gives me y equals 0. And then using x equals minus root 3 in my calculator, that also gives me y equals 0 actually. So my coordinates are root 3, 0, and minus root 3, 0. Then to evaluate the nature of the stationary points, we need the second derivative. So our first derivative, if we remember, dy by dx was 3x squared minus 6 minus 9x to the minus 2. So our second derivative, d2y by dx squared, is going to be 6x plus 18x to the minus 3. So if we substitute in our x values for our stationary points, so when x equals positive root 3, the second derivative, well, if we look at it, it's adding, it's 6x plus 18x to the minus 3. And if x is root 3, both of these things are positive. So the overall is definitely going to be positive as well. So that implies that the pointer root 3, 0 is definitely going to be a minimum. And if we look at when x equals minus root 3, and I'm going to plug that in the calculator now, that's not so obvious. So 6 lots of minus root 3 plus 18 over minus root 3 cubed, that gives me minus 8 root 3. Which is less than 0. That's going to mean that minus root 3, 0 must be a maximum. Then the next part says, can we write down the equation of a line which is a tangent to the curve in two places? So another way of saying that, there must be points on this curve where the gradient is the same in two places. And actually that's the stationary points we've already worked out. The gradient at our two stationary points is 0 in both places. That's what makes it a stationary point. So if we think about a minimum and maximum or any stationary point, the gradient is 0, so the tangent's just a flat line. And but both of them are at y coordinate of 0. So y equals 0 would be a tangent at 2 points and have the same gradient tangent. Question 9 says, integers m and n are both odd. Prove that m squared plus n squared is a multiple of 2, but not a multiple of 4. Well, let's start off by saying, well, if m and n are odd, we can express them as in the form of, like, let's say 2p plus 1, and let's say n is 2q plus 1. And that would mean m squared plus n squared we could write as 2p plus 1 all squared plus 2q plus 1 all squared. Expanding out those brackets, we'd get 4p squared plus 4p plus 1. And plus 4q squared plus 4q plus 1. Collecting the constant terms, we're just going to get 4p squared plus 4p plus 4q squared plus 4q plus 2. So it's definitely a multiple of 2, because if we pull out a factor of 2 from all that, we can do that. So that would leave us with 2p squared plus 2p plus 2q squared plus 2q plus 1. So that's a multiple of 2, i.e. it's divisible by 2. It's not a factor of 4, though, because we can see if we go back to this line, another thing we could write would be, if you pull out a factor of 4 from the first few things, it would be p squared plus p plus q squared plus q, and then leaving the 2 on its own. That would be a multiple of 4, but it's actually 2 more than a multiple of 4. So it's always going to be 2 more than a multiple of 4, so it's definitely not a multiple of 4. So question 10 now says, curve C has equation y equals root 2 over x squared. Can we find an equation of the tangent to C at the point 2 root 2 over 4? Well, the first thing, to find the equation for a tangent, we're going to need the gradient, which we can get from the derivative of our curve. So first, what I'm going to do is rewrite our equation as a power of x. So y would equal root 2 x to the minus 2. If we differentiate that, dy by dx would be equal to minus 2 root 2 x to the minus 3. And then to get the gradient of our tangent, we're going to plug in the x value of 2 from our coordinate. Meaning the gradient of our tangent plugging in is going to be minus 2 root 2 times 1 over 2 cubed. And then one lot of 2 would cancel out, leaving us with 1 over 2 squared, so that'd be 4. So we'd have minus root 2 over 4 for the gradient of our tangent. So our tangent equation must look like minus root 2 over 4x plus c. And then to find our c, we can plug in our point to root 2 over 4. So that would give us root 2 over 4 equals minus root 2 over 4 times 2 plus c. This would simplify down to minus root 2 over 2. And if we add that to both sides, we're going to get c to be 3 root 2 over 4. So the equation for our tangent would just be y equals minus root 2 over 4x plus 3 root 2 over 4. Question 10b now says, show that the tangent to C at the point 2 root 2 over 4 is also a normal to the curve at a different point. Well, that's actually the tangent we just found a minute ago. And they've given us this diagram here to help us visualize it. So there's our tangent going along here. And we're testing to see if it's perpendicular or a normal, same thing, at this point here. I'll call it point P. So to test this, we actually find the point P, and then we can look at the gradient to see if it's actually going to be perpendicular. So to find point P, we're going to need to solve simultaneously with the equation of our tangent and the equation of the curve. So let's start with that. So the equation of our tangent was y equals minus root 2 over 4x plus 3 root 2 over 4. And then the equation of our curve was y equals root 2 over x squared. So I would solve that simultaneously just by substituting out the y's. So root 2 over x squared must equal minus root 2 over 4x plus 3 root 2 over 4. And what I would do here is first I could cancel off all these root 2's. That would leave us with 1 over x squared would equal minus x over 4 plus 3 on root 4. Sorry, 3 on 4. And then what I do is I'd multiply everything by 4 as well as x squared to get rid of all these fractions. So multiplying by 4x squared on the left, that would just leave us with a 4. that's going to be equal to, on the right, the 4 would cancel, multiplying by the x squared, leave us with minus x cubed. And then multiplying the last term by 4x squared, the 4 would cancel, and we would be left with 3x squared. So we've got a cubic left to solve. So to solve that, we're going to bring everything to one side and set the other side equal to 0. So bringing everything to the left, I would get x cubed minus 3x squared plus 4 equals 0, which would be a bit of a faff to solve, really. But we already know a solution, thankfully, because we're trying to find the intersection of the line with the curve, and we already know that there's a solution x equals 2, which would correspond to a factor of x minus 2 in our equation that we have. So we can find the other factors by using long division. So dividing through by x minus 2 onto this. So we're dividing through into x cubed minus 3x squared, and I'm going to write plus 0x because we're missing a power of x. Then plus 4. Doing that, we're going to have x cubed divided by x would leave us with x squared. Multiplying through, x times x squared would be x cubed, minus 2 times x squared would be minus 2x squared. Subtracting off, x cubed disappears, minus 3 minus minus 2, so plus 2 lots of x squared would be minus x squared. And I'm just going to write this plus 0x down here for reference. Now we divide through again, so minus x squared divided by x would be minus x. And then multiplying through, x times minus x gives minus x squared. Minus 2 times minus x gives us plus 2x. Subtracting that away, we get, excuse me, we get minus 2x. And I'm going to bring down the 4, so plus 4. Dividing through again, minus 2x divided by x is minus 2. So we write a minus 2 up here, and then multiplying through, we would get the minus 2x again. And then minus 2 times minus 2 gives us the plus 4, and we do get a remainder of 0. So we know the factors worked. So now our equation must factorize to x minus 2, and then x squared minus x minus 2 equals 0. But x squared minus x minus 2 factorizes further. That actually factorizes to x minus 2 x plus 1. So plugging that in, we'd have x minus 2 squared x plus 1. So the solutions would be x equals 2 or minus 1. Well, we already knew that 2 from before. So that's that one there. So this point P must have an x-coordinate of minus 1. And we don't actually need the y-coordinate. We need to test the gradient at P. So we'll go back to our derivative of, minus 2 root 2 x to the minus 3. So dy by dx was minus 2 root 2 x to the minus 3. And if we plug in x equal to minus 1, what's that going to give us? We'd get the gradient of the tangent at that point would be minus 2 root 2 times 1 over minus 1 cubed. Minus 1 cubed is just minus 1, so that's effectively just going to leave us with 2 root 2. And then the gradient that we're expecting to get for the normal then would be minus 1 over 2 root 2, which we could rationalize the denominator. If we multiply the top and bottom by root 2, we would get minus root 2 over root 2 times 2 would be 2, times that by 2 again would give us 4. So minus root 2 over 4, which was the same gradient as our tangent from before. So we've proven that that tangent is also a normal at another point on the curve. Next is question 11, and it says a car is initially at rest and moves with constant acceleration along a straight horizontal road. One of the graphs below shows how the car's velocity changes over time with t seconds. and we need to identify the correct graph. So there's two pieces of information actually given. So first piece is that it's initially at rest, and then the second piece is it's moving at constant acceleration. So initially at rest means at t equals 0, v is going to equal 0. So that immediately eliminates this graph and this graph because it doesn't start at the origin. Then constant acceleration means the velocity is going to be linear in time. So it's not going to be curvy, in other words. So it's not going to be this one, and the answer is going to be the second option. Question 12 then says, a horizontal force of 30 newtons causes a crate to travel with an acceleration of 2 meters per second squared in a straight line on a smooth horizontal surface. Can we find the weight of the crate? Well, to find the weight, what we're going to do is work out the mass of the crate, because if there's just one force, because there's no friction, acting on our crate to the right, let's say, it doesn't really matter, causing it to accelerate 2 meters per second squared, then we must know that 30, if we think about F equals ma, 30 must equal 2 times the mass. So the mass must equal 15 kilograms, and then that's the mass. So that's not the same as the weight, so we need to multiply by g to get the weight. So that would be 15g in newtons. So watch out for the units there, because they're trying to mess you, like, people would write that and it's given the wrong units. Weights measured in newtons. Question 13 then says 2 points A and B lie in a horizontal plane and have coordinates -27 and 319 respectively. A particle moves in a straight line from A to B under the action of a constant resultant force of magnitude 6.5 newtons. Express the resultant force in vector form. Well, first let's just say this resultant force has component A and B. And then we've been given two pieces of information to find out what those components might be. So the first component, the first piece of information rather, says that it moves in a straight line under this force. So that means the force must be parallel to the displacement between these 2 points. So if we find the displacement between the 2 points by just subtracting them, so that's 319 minus 27. That would leave us with 512. So our force is parallel to 512, or we could say it's just a multiple of 512 then. So AB must be a multiple, we'll say K times 512, i.e. 5K, 12K. Then the other piece of information is that the magnitude is 6.5 newtons. So if we take the length of the vector AB, it must come out as 6.5. So we can do that with Pythagoras to set up an equation. So a squared plus b squared must equal 6.5 squared. And then for a and b, we can use 5k and 12k. So we'd have 5k squared plus 12k squared would equal 6.5 squared. So simplifying that down, we'd get 25k squared plus 144k squared would equal 6.5 squared, which is 169 over 4. Oops. So on the left here, we'd have 25 plus 144 is 169. So 169k squared equals 169 over 4. So we can divide both sides by k squared then actually. So k squared equals a quarter, meaning k would equal plus or minus a half. And we just have to be a bit careful with which solution we take. But if we look at the displacement vector, we've definitely displaced positively in the x and positively in the y. So it's going to be that plus half that we're after. So the solution is going to be when k equals positive a half. So our force vector is going to be, if we set k to a half, it would be 5 over 2, and then 12 over 2, which would be 6. Question 14 then says, a ball is released from rest from a height h meters above horizontal ground and falls freely downwards. When the ball reaches the ground, its speed is v meters per second, where v is less than or equal to 10. Can we show that h must be less than or equal to 50 over g? Well, first off, it's a free fall problem. So if we drop a ball and it's in free fall, we know its acceleration must be g down. And that means it's a uniform acceleration, so we can use Suvat. So it's going to fall a distance h. So let's write out what we know for our Suvat. S would be h. U would be 0 because it says it falls from rest. V is what we're trying to find out, actually, or get some information about. And then A we know would be g, if I'm defining down to be positive. Then to get an expression for v, we can use v squared equals u squared plus 2as. So v squared then would equal 0 squared plus 2gh. So v squared would equal 2gh. And if v is less than or equal to 10, then v squared must be less than or equal to 100. So then if v squared was less than or equal to 100, that would mean 2gh is less than or equal to 100. Dividing everything by 2g, we'd get h is less than or equal to 100 over 2g, which would simplify down to h being less than or equal to 50 over g. Question 15 now says, two particles P and Q are initially at rest at the same point on a horizontal plane. A force of 40 is applied to P and 815 is applied to Q. Can we calculate to the nearest degree the acute angle between the two forces? Well, to calculate an angle, the first thing I would do is think about drawing or visualizing this scenario. So the vector 40 is just purely horizontal because there's no vertical component, it's 0. So we can think about that as a direction as just purely horizontal going out this way. And then a force of 815, let's draw that on. Let's say 8's like roughly here and 15 is this high, say. So that vector would go like this. And it has this distance of 8 and this distance of 15. And it wants the acute angle between these two directions. So that would be this angle here, with this being the obtuse angle, but we're not interested in that. So calculating the acute angle is quite straightforward because we've got a right angled triangle. So we'd know tan theta would equal the opposite of 15 over 8. So theta would be inverse tan of 15 over 8. So running that through a calculator, that gives me 61.927 degrees, but to the nearest degree, that would be 62 degrees. 15b then says the particles begin to move under the action of the respective forces. P and Q have the same mass. P has an acceleration of magnitude 5 meters per second squared. Can we find the magnitude of acceleration of Q? Well, I would start with that piece of information there, that P has an acceleration of 5 meters per second squared. So if we write that out, well, the force acting on P was 40. So 40 must equal the mass times the acceleration vector. Or if we want to write this in terms of magnitudes, well, the magnitude of this force is 4, and that would equal the mass times the magnitude of the acceleration, which would be 5. So m times 5, meaning that the mass must just equal 4 divided by 5, 4/5. And now we've got that, we can go and work out the actual acceleration of Q. So the force acting on Q is 815. So 815 must be 4/5 of our acceleration vector. So multiplying by 5 over 4, so the acceleration vector then would be 8 times 5 over 4 is 10. And 15 times 5 over 4 is 75 over 4. And it wants the magnitude of this acceleration vector for q. Oops. For q. So we can do that with Pythagoras. So the magnitude of q's acceleration is going to be the square root of 10 squared plus 75 over 4 squared. And plugging that into a calculator, we would get 85 over 4. And the units of that would be meters per second squared. Question 16 now says, Jermaine and his friend Mina are walking in the same direction along a straight path. Mina is walking at a constant speed of u meters per second. Jermaine is walking 0.2 meters per second more slowly than Mina. When Jermaine is d meters behind Mina, he starts to run with a constant acceleration of 2 meters per second squared for a time t seconds until he reaches her. So there's a lot of information there. Let's just summarize that. So Mina is walking at a constant speed u, and Jermaine is some distance d behind, and he's walking 0.2 meters per second more slowly. So that would be u minus 0.2 for, this is Jermaine and this is Mina. And then it says they run for t seconds until they reach each other. And can we express that d is t squared minus 0.2t? Well, first off, if they're going to meet each other, basically that means Jermaine is going to have to travel the same distance as Mina, but this extra displacement d. So we can write that for as an equation for Jermaine. So we'll say the displacement of Jermaine must be the same as the displacement of Mina plus d. And we can actually start working out some of these displacements. So the displacement of Mina is straightforward. She's not accelerating. So if we did a Suvat, it would just be s equals ut from s equals ut plus half at squared, because acceleration would be 0. So the displacement of Mina would just be her velocity u times t. Then the displacement of Jermaine, that I will write out the full Suvat for. So, well, we already know it's Sm plus d, which is our ut plus d. We know the initial velocity is u minus 0.2. We don't know the final velocity, but we do know the acceleration of 2 meters per second squared, and we're interested in this time t when they actually meet up. So if we want an equation excluding v, that would be s equals ut plus a half at squared again. And then plugging in what we know, we'd have ut plus d must equal our u, which is u minus 0.2 t, plus a half times 2, which is just 1 times t squared, so just plus t squared. And now if we expand this all out, we'd have ut plus d equals ut minus 0.2t plus t squared. And now we actually just have our result, because the ut cancels on both sides if we subtract it away. And then d would just equal our, if I reorder the terms, t squared minus 0.2t. Now for part B, it says when Jermaine's speed is 7.8 meters per second, he reaches Mina. So that means his final speed, 7.8 meters per second. It says, given that u is 1.4, can we find the value of d from earlier? So let's write out again what we know about Jermaine now. So the displacement of Jermaine, u, we know for Jermaine was u minus 0.2. So u they gave us as 1.4, so Jermaine's starting velocity is going to be 1.2. His final velocity now is going to be 7.8. We knew his acceleration already from the previous question. That was 2 meters per second squared. And then what we can do, if we find this value of t for these values, we can use our previous expression for d to work out d. So an equation of excluding s would be v equals u plus at. So then we would have 7.8 equals 1.2 plus 2t. So then 2t would equal 6.6, meaning t would equal 3.3. And then plugging that into our expression, so d is t squared minus 0.2t. Oops. D is t squared minus 0.2t. And we're setting t equal to 3.3 if we run that through a calculator. So 3.3 squared minus 0.2 times 3.3. That gives us 10.23 for the value of d, and that would be in meters for the distance. So the last question, question 17, we have a car and caravan connected by a tow bar. They move forward together along a horizontal road. Their velocity is v meters per second at time t seconds, where t runs from 0 to 20, and its velocity is given by 0.5t plus 0.01t squared. Show that when t equals 15, their acceleration is 0.8 meters per second squared. Well, if we have the velocity equation, the acceleration is just the rate of change of velocity, so we can differentiate to get an expression for acceleration. So doing that, acceleration would be 0.5 plus 0.02t. And if we set t equal to 15, then we're going to get the acceleration to be 0.5 plus 0.02 times 15, which is 0.8 meters per second squared. Then part B says, the car has a mass of 1,500 kilos, the caravan has a mass of 850 kilos, so I'm just going to mark this on the diagram. So this guy's 1,500 kilo, he's 800 kilo, so 850 kilos. Then it says when t equals 15, the tension in the tow bar is 800 newtons, and the car experiences a resistance force of 100 newtons. So there's a 100 newton force acting on the car, and then there's 800 newtons in the tow bar. So there's an 800 newton force to the left from the tow bar on the car, and 800 newton force to the right on the caravan. And it says, find the total resistance force experienced by the caravan when t equals 15. Well, we also know the acceleration earlier at t equals 15. And assuming this is an extensible bar, the acceleration for the caravan and the truck must be the same, or the car must be the same. So we know the acceleration of the caravan as well then. And there must be some drag force acting on the caravan. So I'll call it capital D. So if we just do F equals ma for the caravan, so I'll do F equals ma, thinking going to the right is positive for the caravan, then we'd have 800 minus our drag force, so 800 to the right minus the drag force going to the left, must equal the mass of the caravan, which was 850, times its acceleration, which we knew from earlier is 0.8. So that would mean the drag force acting on the caravan would be 800 minus this 850 times 0.8. Then running that through the calculator, that would give us a force of 120 newtons. 17b part 2 then says, find the driving force being applied to the car when t equals 15. So if you go back to the diagram, if this guy is accelerating to the right at 0.8 meters per second squared also, then there must be a driving force, like they say, acting on the car. So we can do a similar calculation for the car now. So just doing F equals ma going to the right for the car. Well, we've got the driving force that was going to the right. We need to take away the 800 from the tension and the 100 they mentioned from the resistance acting on the car. So minus the 800 from the crowbar minus the 100 drag force. Then we would have to equal that to the mass of the car, which was 1,500. Oops. 1,500 times the car's acceleration, which was also 0.8 meters per second squared. And then rearranging here, we'd have D would equal, it would be 900 if we brought those over to the other side, plus 1,500 times 0.8. So plugging that into a calculator, that would give us 2,100 newtons. State one assumption you have made about the tow bar. So I mentioned that earlier, actually. If the acceleration is going to be the same for the car and the caravan, it must be an inextensible bar. So that will be our assumption. Tow bar is inextensible. That's it for this video, guys. Hope you found it helpful. If you're looking for some one-to-one tuition, you can check out my website using the link in the description. Thanks, and I'll see you in the next one.